Now we have covered the activity network, critical path, and so on. Those are the common knowledge if you take any project and management course. Let's push the line a little further. We introduce some probability estimations here, which is not usually available on the project management textbooks. Now, the reason we do that is because we estimate the time for each activity. We give it a unique time. Sometimes I would say most of the time, the situation can be a little more complex than that. This is the following is something that works better than the previous single unique estimation. Assume that we have activity network. For each activity, instead of have one estimate, now we're going to have 3 estimates. The 3 estimates are the earliest possible time, and we're gonna label it as A, most likely time to finish that single activity, and we label it as M, and latest possible time we label it as B. We make an assumption that the activity time follows a beta distribution. This one works at a lot of places. If we do not have any prior knowledge of those activities, then we start from here. Later on, of course, we can adjust it. The expected time for a activity is T equals to A plus 4 times M plus B divided by 6. So A, M, B comes from here. The variance is V equals to B minus A divided by 6 and take a square. Now B minus A comes from here. Let's use an example to learn this. Now we have the same example from Milwaukee General Hospital project. We have activities from A to H. Now instead of having one single unique estimated time for each activity, now we have 3. The earliest possible time to finish activity A is 1 week. Most likely 2 weeks. Latest possible 3 weeks. So what is the expected time for activity A? It is A plus 4 times M plus B divided by 6. So we plug in numbers of A, M, B into this formula. And it's right here. So 1 plus 4 times 2 plus 3 divided by 6 equals to 2. So the estimated time for activity A is 2 weeks. The variance equation is here. We plug in B and A. So the variance for activity A is 3 minus 1 divided by 6, take square is 0.11. We do the same thing for B, C, D, E, F, G, H. So I have done that, and they're listed here. So we have expected time for each activity and the variance for each activity. Now the project time, expected time for the whole project is the sum of activity times the estimated time t on the critical path. The variance is the summation of activity variance on the critical path. From our earlier work, we have this critical path for Milwaukee General Hospital project. It is ACEGH. So it's in this column. And these three columns are the corresponding earliest possible time, most likely time, latest possible time for the activities on the critical path. So basically, we take out the critical path part of our last table, and this part is the expected time for critical path activities. So we have A, the estimate expected time for activity A equals to 2, for B equals for C equals to 2, for E equals to 4, for G equals to 5, for H equals to 2. The variance for activity A is 0.11, C 0.11, E 1, G 1.78, H 0.11. So the expected project time for the whole project is the summation of this column. What are the numbers in this column? It is the expected time for activities on critical path. So it is t equals to 15. The project variance is the summation of numbers in this column, which are the variance of activities on critical path. So it's going to be something like this. And the summation, the result of the summation is 3.11. And of course, this is simple. From statistics, we know that the standard deviation is always the square root of variance. So take the square root of 3.11, we get the variance. That is 1.76. There is a exercise available for you to work on. The answer key is also provided. Also, thank you very much.